Hello, everyone. Welcome to today's presentation. I'm excited to be here with you. Today, we'll be exploring the fascinating world of physical and chemical changes. The title of our presentation is Physical and Chemical Change. We'll look at what distinguishes these two types of changes, how they occur, and why they are important in understanding matter. So, let's get started and discover the differences together. Let's start with understanding what we mean by change. Change refers to the process by which something becomes different from its original state. In science, we categorize changes mainly into two types, physical and chemical. Recognizing these types helps us understand how materials behave and interact in various environments. As we go through the presentation, we'll explore these changes in detail, highlighting their characteristics and significance. This foundation is essential because it connects to important topics like rusting, which is a chemical change, and methods we can use to prevent or control such changes. So, keep this idea of change in mind as we proceed. You'll see how it ties into the bigger picture of material science and everyday life. So, what do we really mean by change? Well, at its core, change is about becoming different or taking on a different form. It's not just about small adjustments, but about shifts that can significantly alter how things are or how they function. When we talk about change, we're referring to a process, something that involves moving from one state or condition to another. This concept is fundamental because understanding change helps us navigate transitions more effectively, whether in our personal lives or within organizations. Recognizing that change means becoming different allows us to see it as an opportunity for growth and improvement rather than just a challenge. Throughout this presentation, we'll explore how embracing change can lead to positive outcomes and help us adapt to new realities. Now, let's take a look at the different types of changes that matter when we're talking about matter itself. First, we have physical changes. These are changes that affect the form or appearance of a substance, but don't alter its fundamental identity. Think of melting ice or tearing paper, things that can be reversed or changed without creating a new substance. On the other hand, we have chemical changes. These involve a transformation at the molecular level, creating new substances with different properties. For example, burning wood or rusting iron. These changes are usually permanent and often involve energy transfer, like heat or light. Understanding these two types of changes helps us grasp how matter behaves and transforms, which is a core part of our overall study of chemistry. Recognizing whether a change is physical or chemical can tell us a lot about what is happening at the molecular level and how we might control or utilize these changes in real-world applications. Now let's talk about physical change. A physical change occurs when a substance undergoes a change in its physical properties. What does that mean exactly? Well, it means the substance might change its appearance, shape, size, or state, like melting, freezing, or dissolving, but its chemical identity remains the same. This is an important concept because it helps us differentiate between physical and chemical changes. Physical changes are usually reversible, which is a key point to remember. They're fundamental to many everyday processes, and understanding them helps us see how materials behave without altering their chemical makeup. So, in the bigger picture, recognizing physical changes allows us to better understand the nature of matter and how we interact with it daily. Let's talk about the characteristics of a physical change. First, only the physical properties of the substance undergo change. This means that during a physical change, things like shape, size, or state might change, but the actual material remains the same. No new substance is formed, which is a key point. You're not creating something new, just altering how it looks or behaves physically. Physical changes are usually reversible, so you can often undo them. For example, melting ice into water and then freezing it back into ice is a classic physical change. And importantly, very little energy is absorbed or released during these changes, sometimes none at all, making them quite different from chemical changes that involve energy exchanges. Understanding these points helps us see how physical changes fit into the bigger picture of matter and its transformations. They're typically simple, reversible, and involve just physical properties, not the substance itself. Now let's talk about chemical changes. A chemical change happens when two or more substances react together and form a completely new substance. This is different from a physical change, where the substance might change form but not its identity. In a chemical reaction, we often represent it with the equation A plus B equals C here. O and B are the reactants, the substances we start with, and C is the product, the new substance that is formed. Understanding this process is key because it helps us see how substances transform in everyday life, from cooking to industrial processes. Remember, a chemical change results in something new, with different properties from the original substances. All right, let's talk about some key characteristics of chemical change. First, when a chemical change occurs, new substances are formed that have different properties from the original materials. This means the identity of the substances changes entirely. For example, when iron rusts, it transforms into a new substance with different characteristics. Another important point is that chemical changes are generally irreversible. Once the new substances are formed, it's usually very difficult or impossible to turn them back into the original materials. This is a fundamental difference from physical changes, which can often be reversed. And finally, during a chemical change, a significant amount of heat is either released or absorbed. This energy change is a key indicator that a chemical reaction has taken place. It highlights how chemical reactions involve energy transfer, which is crucial for understanding processes like combustion or cooking. Together, these characteristics help us distinguish chemical changes from physical ones and deepen our overall understanding of how substances interact and transform. Let's now talk about the rusting of iron. Rusting is a common chemical process that happens when iron reacts with moisture and oxygen from the environment. This reaction forms a new compound called iron oxide, which we see as rust. Rust weakens the metal and can cause structural failures if not managed properly. It's important to understand that rusting is an example of corrosion, a broader concept that affects many metals. This process highlights the importance of protecting metal structures through coatings or other methods. Connecting this to our overall theme, rusting reminds us of the need for corrosion resistance in engineering to ensure safety and longevity of metal components. So let's talk about rusting. Rusting is actually a specific term we use to describe the corrosion of iron. It's a chemical reaction that happens when iron comes into contact with air and water. When this reaction occurs, what you see is a reddish-brown coating forming on the surface of the iron. That coating is what we call rust. More technically, rust is iron oxide. This reddish-brown layer isn't just a surface stain. It actually indicates that the iron is breaking down due to this chemical process. Understanding rusting is important because it helps us grasp how materials degrade over time and why protective measures are necessary to prevent damage. Let's now look at how we can prevent rusting effectively. One common method is galvanization, which involves coating the metal with a layer of zinc. This zinc layer acts as a sacrificial barrier, meaning it corrodes instead of the metal itself, providing long-lasting protection. Another important approach is alloying, where we combine the main metal with other elements to enhance its resistance to corrosion. For example, adding chromium to steel creates stainless steel, which is much more resistant to rusting. Both of these methods are crucial in extending the life of metal structures and components, especially in harsh environments. Understanding these prevention techniques helps us choose the right treatment for different applications, aligning with our overall goal of maintaining durable, rust-free materials. Let's talk about galvanization, which is a really important process in protecting iron objects. Essentially, galvanization involves depositing a layer of zinc onto the surface of the iron. Now, why zinc? Because zinc acts as a protective barrier. When zinc is applied to iron, it reacts with the air and forms zinc oxide on its surface. This zinc oxide layer is crucial because it creates a barrier that prevents the iron underneath from coming into contact with oxygen and moisture in the atmosphere. This barrier significantly slows down the rusting process, which is a major concern with iron and steel structures. So, in a way, Galvanization is like giving iron a shield that helps it last longer and resist corrosion. Connecting this to our overall theme, galvanization is a practical and effective method of corrosion protection, especially in environments where iron objects are exposed to harsh conditions. It's a great example of how understanding chemical reactions can lead to real-world solutions for durability and longevity. Now let's talk about alloying. Certain metals can actually be made rust-free by mixing them with other metals that resist corrosion. A great example of this is stainless steel. It's an alloy, which means it's a blend of different metals, specifically iron, nickel, and chromium. Because of this combination, stainless steel doesn't rust like pure iron or steel would. This process of alloying is a clever way to improve the properties of metals, especially when we want materials that are durable and resistant to the elements. It really ties into the overall theme of how we can enhance metal characteristics to better suit our needs. Now, let's wrap up with crystallization. Crystallization is a fascinating process where we obtain pure crystals from an impure substance. Think of it as a way to filter out the impurities and leave behind only the pure, beautiful crystals. Crystals are actually the purest form of a substance, which makes them incredibly important in various scientific and industrial applications. Understanding how to produce pure crystals through crystallization helps us improve the quality of materials like pharmaceuticals, chemicals, and even food products. So, by mastering this process, we can ensure the highest purity and effectiveness in many products we encounter daily.